Hello students, today we will talk about the fundamental particles. But before discussing what are the fundamental particles, you must have the information about the atom. What is atom? You know, all the matter is composed of atoms, which are smallest parts of an element that can take part in the chemical reaction. Atoms are mostly made up of empty space around a very dense nucleus that contains protons and neutrons. So, this is the nucleus, as you can see in this picture. It is consisting of neutrons and protons. Now, the question arises, what is the charge on nucleus? Nucleus has an overall positive charge because the proton have positive charge and neutrons have a neutral charge. That is why nucleus exhibit overall positive charge due to the presence of protons, because protons have positive charge. However, neutrons, they are neutral particles. That is why they don't contain any charge. The overall charge on nucleus is positive due to the presence of protons in them. As you can see in the atomic structure around the nucleus, there are some circular paths or orbits. These are the paths in which the electron revolve. So negatively charged electrons are found in the orbits and empty space around the nucleus. In any of their fixed orbits, electrons can revolve around the nucleus. And this is about the structure of an atom. Now, what if we talk about what are the subatomic particles? Subatomic particles are the particles like an element is made up of, which include electrons, protons, and neutrons. These subatomic particles, they are so small that it is not possible to measure their masses and charges using the conventional units. So you can see that when we need to measure the charge and the mass of these subatomic particles, they are so small we cannot measure them in grams or coulombs. Instead, like their masses and charges are compared to each other using the relative atomic masses and relative atomic charges, because subatomic particles are so small that it is not possible to measure their masses and charges using these conventional units of grams and coulombs. So you need to know about this thing as well. These are not the actual charges and masses, the relative atomic masses and relative atomic charges. They are not actual. Instead, they are the charges and masses of the particles relative to each other. So as you can see, I have displayed over here a table for you. You can easily see in this table that the protons and neutrons have a very similar mass. So each is assigned a relative mass of 1, whereas electrons are 1836 times smaller than proton and neutron. Moreover, protons are positively charged particles, electrons are negatively charged particles, and neutrons are neutral. They don't have any charge on them. But for exam point of view, you must remember this thing, that relative mass of electron is almost negligible. The relative mass of electron is almost negligible, and the charge on single electron, you can see it is minus 1.602 times 10 raised to power minus 19 coulombs. Whereas if we see the charge on proton, it is plus 1.602 times 10 raised to power minus 19 coulombs. However, you can see relative to each other, their charges are just minus 1 and plus 1 respectively, but they have got the same value. And let's talk about how can we represent the atomic mass and atomic number, and what information do the atomic mass and atomic number of an element gives us. So the atomic number, it is written over here, it is represented by Z. So the atomic number, it is also called as proton number. It is the number of protons in the nucleus of an atom, and it has the symbol Z. The atomic number is equal to the number of electrons as well present in the neutral atom of an element. For example, let's suppose like lithium. If I talk about lithium element, this is the element of group first. So if I talk about lithium, lithium has atomic number 3 for. So if it has the atomic number 3, it indicates that neutral lithium atom, it has 3 protons and 3 electrons. So atomic number is equal to the number of electrons as well as number of protons present in the neutral atom of an element. And what about the mass number? Mass number, it is also called as nucleon number. It is the total number of the protons and electrons in the nucleus of an atom, and it is represented by the symbol A. So how can we find out the number of neutrons in an atom? It is simple, that number of neutrons can be found by subtracting mass number by atomic number. You can simply see number of neutrons equals mass number minus atomic number, because mass number is the total number of protons and neutrons in the nucleus. So that is how you can easily find out the number of neutrons by subtracting the mass number with atomic number. Because you need to remember, for exam point of view, this thing as well, that protons and neutrons, they are collectively called as nucleons. That is why the mass number is often called as nucleon number. So don't confuse with the terms. It is same. Mass number or nucleon number is the same. Okay, let's practice now some of the questions. For example, if we have got a question, which of the following has greater number of neutrons, and our elements are hydrogen, helium, carbon, and nitrogen? How will I find out the number of neutrons, greater number of neutrons? Let's see. For hydrogen, I have got this at the top. I have got the atomic mass or mass number. This is 3. So 3 minus 1 equals 2. So here for the case of nitrogen, I have got 2 neutrons. Okay, let's talk about helium. The atomic mass of helium is 4, or the mass number is 4. Atomic number, it is 2. 4 minus 2, it is 2. So here we have got 2 neutrons. For carbon, carbon has the atomic mass or mass number 12. It has the atomic number 6. So 12 minus 6 equals 6. Okay, about the nitrogen, has the mass number 14. Its atomic number is 7. So 14 minus 7 is 7. So which of following has greater number of neutrons? You can easily see nitrogen has got greater number of neutrons. For example, the question is now changed. Which of following has smallest number of electrons? Okay, so don't confuse with this question. We know that the atomic number or the proton number, also in the case for neutral atoms, that also tells us information about the number of electrons. So in here, the atomic number is 1. For this, it is 2. For this, it is 6. For nitrogen, it is 7. So obviously, hydrogen has only 1 electron. So this is the right answer. For example, if I will change the question, I will ask you that which of the following has greater nucleon number? So nucleon number is same as the mass number. Don't confuse with that. So it is in case of nitrogen, the nucleon number is 14. So in that case, the answer could be nitrogen if I will ask you about the greatest nucleon number.